In this question, there is a GS geometric sequence, and then the third term and the seventh term are given. So the third term is 21, while the seventh term is 189. What happened between them is every time we are going to multiply R. So our very straightforward things is from 21. We multiply R for 4 times, that means times R power 4 will become 189. So we have this relation, and it's helped us to find out R. If we know what is R, we chase back 2 times, then we get the first term. So we try to solve R first. To solve R power 4, we try to take square root first, then it will become R power 2. Positive negative square root 9, so which means R squared can be either positive 3 or R squared equal to negative 3. But we all know that R squared should be positive, it can't be negative, so this is rejected. And then for this part, we try to square root both sides again because what we really concern is common ratio R power of 1. So R equal to square root 3 or R equal to negative square root 3. Both these roots will lead to this result, and we don't have any other information to reject any one of the solution here. R can be negative square root 3. So whenever we judge this kind of statement, is that always true or not, then we have to consider both cases because the questions say that must be true. What we are finding are must be true statement. So now we have two cases. Case 1, we have R equal to square root 3, and then we also have another case, case 2, R equal to negative square root 3. If we look at the first case, the common ratio is less than 1. The case 1, this is larger than 1. However, in the second case, this is smaller than 1. Therefore, the first statement is not always correct. We can't accept the first statement. And then about the second statement, we have to find out is there some term irrational. It's because our ratio are irrational number. So, if we consider the starting point is 21, if we multiply square root 3, it will become 21 square root 3 or negative 21 square root 3. No matter what ratio it is, it will create irrational number because of the square root 3. No matter what is the sign, is that positive or negative, it's not important. But square root 3 will create irrational, so this is always correct. We accept the second statement. Now is the last one. The sum of the first 99 term of the sequence is greater than certain values. So to reject this statement, if we try to find the minimum values of these two cases, of course I will focus on here, is because sum of the term is negative. So they will, if we add all these together, it will make the result smaller and maybe smaller than this, then we can prove that this is wrong. Alright, so we work on the second case and we need to find out what is A in order to use the formula. So by using A, that means divide by square root 3 and then divided by negative square root 3 again. So we get 21 over 3, so which is equal to 7. We have the first term equal to 7. Now we have all the things we need for the target. The first 99 term add together as 99. The formula is the first term and then r power of n minus 1 over r minus 1. So A is 7 and then r is negative square root 3. Power of 99 minus 1 over negative square root 3 minus 1. If we use calculator, it gives us 1.06 something times 10 power of 24 only. So this is much less than 3 times 10 power of 24. That's why this is not always correct. Only statement 2 is always correct. If we find this value is greater than 3 times 10 power of 24, then this case should be larger. It's because all the terms here are positive. So you don't need to calculate this. If we are asking for the minimum value, this one must be smaller. It saves some of your time.